So now we have number 3, and this is limit x tends to 0 root over 1 plus x minus 1 divided by x. So this part is little tricky because here we have a composite function, right? So sorry. The important thing is here if we just put the value here x equal to 0, then this part will become 0. And if we also input x equal to 0 here, so it will be also root over 1. That means 1. So 1 minus 1, it will make 0, right? So we can see that it is like a 0 divided by 0 format. So if a function that is 0 divided by 0 format, we have to use Lapitas rule, okay? And Lapitas rule is like we have to differentiate the upper function and also the lower function. You have to differentiate.
Bro, how can we get 0? 1 minus 1? There is no 1 minus 1, I guess.
No,
If you put 1 plus 1, it will be root over 2 minus 1.
No. You input this value here, x equal to 0 here. So it will become root over 1 plus 0. That means root over 1.
Got. Sorry,
okay,
I made mistake.
It's okay. So we have to, Lapitas rule is we have to differentiate the upside function and downside function, okay? Or numerator and denominator separately. So derivative of our upside function. So sorry, not this part here. The part is here. So this is our upside. This is our numerator, and this is our denominator. So the Lapitas rule is we have to differentiate these two functions separately. So for example, I just did it here. So root over 1 plus x minus 1 derivative. So this is like, firstly we are using sum rule. Sum rule means derivative of this function minus derivative of 1. So we know that derivative of 1 is equal to 0. So we can skip this one, right? And we can take this root over 1 plus x, and we can find the derivative of root over 1 plus x. So root over 1 plus x, we know that for root over, the power is 1 plus x to the power 1 plus x to the power 1 by 2, right? Root over 1 plus x means 1 plus x to the power 1 by 2. Now we can take this power down from the formula, and we can increase the power by minus 1, okay? So if I calculate this half minus 1, so it will become minus half. So minus 1 into 1 plus x to the power minus half. And see here we have inside we have again 1 plus x. Inside we have 1 plus x. So we have to think this is like u, okay? So here we cannot do normally, so we have to use chain rule. So the chain rule is outside derivative of outside function and multiply derivative of inside function. So inside function is 1 plus x, okay? And outside function is root over 1 plus x. So we just let 1 plus x equal to u. We let 1 plus x equal to u, okay? So it will be root over u. So firstly we have to differentiate the outer function. So root over u will be u to the power half. So, and then we have to multiply the inside function. So inside function is what? 1 plus x. 1 plus x, okay? And the derivative of inside function. So root over u, that is u to the power half, and we can also write down this way. Now if we want to find the derivative of root over u, it will be half u to the power half minus 1.
U half minus 1.
Yeah.
That will be minus half.
So it will be minus half, right? So I'm showing you the same step here, okay? The same thing here. Just explaining like how we calculate or how we use chain rule. So then we just substitute the value of u. So this will be half into 1 plus x, right? 1 plus x to the power minus half. So maybe I don't need to explain this part, because this part here and the thing I just wrote here are the same, okay? So we are calculating here root over 1 plus x derivative. It will be half into 1 plus x to the power minus half. And then again, because we are using chain rule, so we have to differentiate the inside function. The inside function is 1 plus x. So derivative of 1 plus x will be only 1, okay? So now we get 1 by 2 into root over 1 minus x. Because something to the power minus half, we can just write down root over, okay? Root over. For example, 2 to the power minus half, we can write down like this way. 1 by root over 2. Okay?
Okay.
So now we found that the derivative value of this numerator, this is only 1, right? This is this is 1 by 2 root over 1 minus x, right? And derivative of this denominator, this is x. So we know that derivative of x is equal to 1, right? So we don't need to write this one on the downside, because we know that 2 by 1 is equal, 2 by 1 is the same like 2. So this is our now we can just substitute x 0 here. If you substitute 0 here, it will make 1 by 2 root over minus 1. So
I have not got second line, brother.
This line?
Yeah, this line.
So we already found the derivative value of our numerator,
yeah,
right?
we have got already, but how can we get
so
we
write it here. We write it here, okay? Directly we write it here. And then on the downside, we have x. So derivative of x is 1. Derivative of x is 1. So you do not need to write divided by 1 here, because this means the same, okay? Because you know 2 by 1,
got it.
2 by 1 is equal to 2.
Okay, got it, brother.
Okay. So now you can just substitute 0 here. So if you substitute 0 here, it will make 1 minus 0. That means root over 1. Root over 1 is equal to 1. So 2 multiply 1 is 2. So in total, this is half. Okay, guys, can you understand?
Yeah, got it.
Julian, Farin, what about you guys?
Farin or Khadija?
But during class, I think I understood the realization method better.
Okay, so this is the Lapitas rule, okay? You just find the derivative of numerator and denominator, okay? So Farin, do you understand?
Yeah.
You can ask me, no problem. We are just having discussion, open discussion here.
Okay, but I do understand.
Okay, thank you. So now we are moving to our main topic, that is integration, okay? So integration is the opposite form of differentiation. So in differentiation, we find the slope, right? We find the slope. So differentiation means the slope of a specific point, okay? For example, this is our function. So if I tell you just find the slope here. So you just make a tangent line. You just make a tangent line at this point and you get the slope, right? Slope means m. So the differentiation means the slope or the changing rate, like you are throwing a ball and you want to find the changing rate of its velocity. Okay, so we can find the changing rate at any point if we just differentiate the function at those points. And integration means the area of the function. For example, if I tell you like from here is like a, so imagine this point is a and this point is b. Okay, and I'm telling you that find the area between a and b. So the area will be like this, right? This part. So you can imagine a lot of rectangle inside of this a and b interval, right? And if you add all those small rectangles, it will make the area, right? It will make the area uh, of of this interval. So integration means to find the area, and differentiation means to find the slope, right? Okay. So differentiation and integration, they are opposite term. So here we have some example. F of x is equal to cos x and f of x is equal to 2x plus cos x. So we have to find the antiderivative. Okay, antiderivative means integration. So you have to find the antiderivative of these two functions. So you know that the derivative of sin x, it is cos x, right? So in the same way, derivative of cos x will be derivative of cos x is minus sin x, right? So here we have cos x. So how do we find cos x? If we derivative this function sin x, then we find cos x, right?
I guess it will be minus sin x.
No. So we are just it will be minus sin x. It is not that example. We have a function f of x is equal to cos x.
If we derivative of cos x, then it will be minus sin x.
Yeah. If we derivative cos x, it will be minus sin x.
But in solution, it is only sin x. Solution number 1. Can you say?
Yeah, I can see. So this is the function. It is cos x. We have to find the
Yes.
antiderivative. Okay. So we found antiderivative is sin x. So how do we found? So
Okay.
if you just differentiate this sin x, you can get cos x. So the idea is if we differentiate our answer, we can get back to our antiderivative. Okay. So that's why the antiderivative of cos x will be sin x.
But as far as I know, actually, if I convert sin x to cos x, then it will be.
I will give you more example and it will be more clear. Okay. I will show you how to when it will be minus cos x and so on. So then we have f of x is equal to 2x plus cos x. So we know that 2x, right? So if we derivative x square, so it will become 2x, right? And if we derivative sin x, it will become cos x. So this is our answer, x square plus sin x. So how do I find this? So to find this, we need to remember some formula. And here is all the formula, okay? All the basic formula. Okay. So for example, we have so let me show you number 2, okay? 2x plus cos x. So how do we find 2x, antiderivative of 2x will be x square, right? So we can find it here. We can find it here, okay? X to the power, integration of it will not be function. It is not function. This will be integration. Okay. By mistake, maybe I wrote this. So it will be integration k dx. It is kx plus c, and integration x to the power n dx. This is 1 by n plus 1 x to the power n plus 1 plus c. So all these are the formula for integration. So you can see that integration of x to the power n dx is 1 by n plus 1 into x to the power n plus 1 plus c. So we have 2x. So you can write this way. You just take write 2 here, and you just keep 2 here. Okay. You just keep 2 here, and then x. So as the power, we have x to the power 1, right? So we keep 2 here, and we write x. And according to our formula, we know that it will be x to the power 1 plus 1, right? And divided by 1 plus 1. You see the formula here? X to the power n plus 1 divided by n plus 1, right? So I write this way. So it will make...
The first was 1 by n plus 1. So what is it?
It is the same, bro. If you just want to write it here.
Okay,
can
you go our formula again?
Yeah. This is the formula.
This is the formula 1 by n plus 1.
They are multiplied, right? They are multiplied. So you can also write this down here. Like you can also write this down here. Okay, like this one. And you can skip this one, because 1 multiply x to the power n plus 1 is like the same.
Okay.
It is the same. Okay. So x to the power n plus 1 by n plus 1. This part and the thing I written here, they all are same. Okay. So this thing and this thing, they are same.
Got it.
So you can see, just I wrote 2 here, right? And here was 1 plus 1. So 1 plus 1 will make 2, and on the upside we have x to the power 1 plus 1. That means x square, right? So this 2 and this 2 get cancelled, and we get our final result x square. So this way we calculate antiderivative or integration. Okay.
Yeah, but how can we get a sin x from cos x?
Okay, so you already know from the formula that derivative of sin x equal cos x. So we don't need to go through.
Okay, as far as I know, it is minus cos x. Am I right or wrong?
It is the formula of integration, but we are thinking here about the differentiation or the derivative. Okay.
Okay, got
because
it.
Because we have not yet reviewed those formulas. By now we only know the formula of differentiation. So when I get back to the formula of integration, then it will be like very simple, like water. Okay.
Water is not easy.
Okay, so let's go. Let's review our... I have a text here. Okay.
Oh.
We have...
This is a hard job.
Yeah, we have 2 person. Who is O 037121114? May I know your name?
Masedi.
Oh, Masedi. Yeah, I remember you. Yeah. So
Masedi.
So now we are going to review some formula of integration. Okay. So we have firstly integration of k dx. That means integration of a constant. It will be that constant multiply x plus c. Okay. So here k is a constant. So integration of a constant is constant multiply x plus c. Okay. And then integration of x to the power n dx. It will be 1 by n plus 1 into x to the power n plus 1 plus c. This is the second formula. And the third formula is integration of 1 by x dx is equal to ln x plus c. Because from the derivative formula, we know that derivative of ln x will be 1 by x. And remember to write this modulus sign or the absolute value sign, okay? And number 4 is integration of cos x dx is sin x. Because from differentiation, we know that the derivative value of sin x will be cos x. So differentiation and integration, they are just opposite, okay? They are opposite to each other. And integration of sin x dx, it will be minus cos x. So why? Because you know that derivative of cos x will is equal to sin x, right? From the derivative formula, we know that derivative of cos x is equal to, minus sin x. Derivative of cos x is equal to minus sin x. So we are calculating
for this math, it is not minus sin x, I guess.
So we are calculating integration of sin x. Okay, we are not taking integration of minus sin x. That's why this symbol becomes minus. Or you can just say that this minus goes on the opposite side with cos x. Okay. You see here we have minus sin x. Derivative of cos x is equal to minus sin x. But in the formula, yes, we are taking sin x. That's why we get a minus sign on the with cos x. Okay.
If we derive it to sin x, then it will be minus cos x. Am I right?
So if I take here minus sin x, maybe it will be cos x only. Okay. Yeah. So
actually, I'm little bit confused about it, brother. I know I'm questioning again and again.
No, it's okay. It's okay. No problem. So we know that derivative of cos x is minus sin x, right? So
okay,
integration of minus sin x would be cos x plus c, right? But we are taking here what? We are taking here sin x. We are not taking minus sin x. That's why we get this minus sign here. Or you can just imagine like this minus goes on the opposite side and we get minus cos
okay.
x.
Then if a derivative to sin x, then it will be minus cos x. But if you derivative to cos x, then it will be only sin x.
Yeah,
am I right?
Right.
Okay, clear.
So number 6, we have integration of e to the power x dx. And also from the derivative formula, we know that derivative of e to the power x, it is also e to the power x. So in integration, we must type this c, and this c is a constant. Okay, we must type this c because derivative of sin x, derivative of sin x plus 6. This is also cos x, right? So we have to write this constant like c. Okay. And derivative of sin x, this is also cos x, right? They are same. Derivative of sin x equal to also cos x, and derivative of sin x plus maybe 10. This is also cos x. That's why you have to write this c, because c is a constant. We can take any constant here. Okay. And then we have derivative of sec square dx. It is tan x plus c. Because from the derivative formula, we know that tan x, the derivative of tan x is equal to sec square x. And derivative of sec x tan x is sec x. Because, not derivative, integration. Sorry, I mistake here. Integration, okay. Integration of sec x tan x dx will be sec x, because we know that derivative of sec x is sec x tan x. And derivative of integration of on by on plus x square. Integration of on by on plus x square dx. It is arc tan x, because from derivative formula we know that arc tan x is a derivative of arc tan x is on by on plus x square, okay? And arc means tan inverse. Arc means tan inverse, okay? Tan inverse x. So in our scientific calculator, we have tan inverse x. Okay, guys? So now let's go to number 10. We have integration of 1 by root over 1 minus x square dx. So the formula is arc sin x. So you look at the sign here. Here is plus and here is minus. And also here is another thing, that is root over. Okay. So this is the all formula for integration. Okay, guys. Now let's see some example. We have integration of minus 2 cos x dx. We have integration of minus 2 cos x dx. So we can just take this constant out, okay? So we just take this constant out, then we get integration of cos x dx. And from the formula, we know that integration of cos x will be minus, integration of cos x will be sin x, okay? Sin x plus c. So in together, this is minus 2 into sin x plus c. The second one, we have integration of x plus 1 dx. So here we can use sum rule, right? Like integration of x dx and integration of on dx. So from the formula, we know that integration of a constant value, it will be constant into x, right? Constant into x. Here I didn't write c. Here will be a c, okay, plus c. Constant into x. So this is the on into x means only x. And here we have integration of x dx. So what do we do here? So we just increase the power. Here the power was 1, so we increase the power by 1, and then also we divided by power. That means 1 plus 1. So it will make x square divided by 2. Okay. So the whole answer is x square by 2 minus x plus x. Now, x square plus 2 plus x plus c. Okay. Remember to write down this c.
Can you repeat again, brother?
Yes, I can. So from the formula, we know that integration of a constant. This is constant. This is constant into x, right? So here our constant is 1. So 1 into x means only x, right? So we write down x here. And here we have integration of x dx. So from the formula, we know that integration of x to the power n dx. This is 1 by n plus 1. This is, you can just simply write down this way. This is x to the power n plus 1 by.
Can you show this formula from our formula rules?
Yes, I can.
Please.
This is the formula, number two formula here.
X and dx, 1 plus 1, x 1 plus 1.
Okay.
Okay.
You can just like this way, okay? So it will be x to the power n plus 1 by n plus 1.
Okay.
So now, if I just calculate here, so x to the power 1 plus 1 by 1 plus 1, right? So this is x square by 2. X square by 2. Okay, guys. Then we write down plus c here because, yeah. If you don't understand, just ask me because I'm not your teacher. So.
Yeah. Okay, Laushi.
Not Laushi. You can just call my name. So number 3. Number 3, we have integration of 2x cubed minus 5x plus 7 dx. So like we have here 2 into x cube, right? So we keep 2 outside, okay? We keep 2 outside. So then we get x cube, right? X cube. So we know that integration of x cube dx, it will be x to the power 3 plus 1 by 3 plus 1, right? From our formula. So we write down 2 into x to the power 3 plus 1, that means 4, divided by 4. So if you just cancel this 4 and 2, then you get 2 here. That means x to the power 4 by 2. Okay, x to the power 4 by 2. And
this is same formula.
Yeah, same formula. And integration of 5x dx. So we know that integration of a constant and x. So again, we just increase the power and we divide it by the power, okay? So it will be 5 into x square by 2, right? Or you can say that 5 by 2 x square. Okay, so or 5x square by 2. You can just take it closer here, okay? 5x square by 2.
We can divide by 2 for 5.
No need, we don't need. Just keep it as it is, okay? And for integration of 7 dx, we know that it will be 7 into x, right? Because kx, do you guys still remember kx? Integration of a constant value. That is constant value multiply x. So we have 7x. And at last we just write plus c. So
How can we get 7x? It is same formula.
It is number on formula. Integration of a
kx.
constant value, yeah, kx. Integration of a constant value is kx plus c.
Kx plus c. Okay.
Now let's see number 4.
Then what is the k here?
Here k is 5. Here k is only 7. Here k is 7. Okay.
K is 7 and x is there. Okay, got it.
So these are very simple, right? Julian, Zakira, Farin. Then
They are talented.
Yes.
They can understand everything.
Yeah.
Yes.
Also number 14. Your name was like I forgot. Masedi, right? Masedi. Yeah.
Yes.
Masedi, do you understand?
I understand.
Okay, thank you. So these are very simple, but we are getting, we will discuss about complex integrations just after a moment, okay? So number 4, this is also very simple. We have 1 by x square and x square and 1 by 3. So 1 by x square. So this is like, okay, let me explain. Integration of 1 by x square. So again, we can just 1 by x square, you can write down this way, x to the power minus 2, right? So the answer is x to the power minus 2. We just increase the power by plus 1 and we divide it by power. So it will be x to the power minus 1, x to the power minus 1 by x to the power minus 1 by minus 1, right? So we know that x to the power minus 1, we know that x to the power minus 1, this is, okay, before that, let's multiply using minus here. So we multiply minus on the upside and also on the downside, okay? So then we get minus.
Brother, can we divide by -1 and -1? Oh no, we cannot divide because it is power.
Yeah.
And it's not power. Okay, got it.
So then we get minus minus, that means plus. So and here it is minus. So we get x minus x to the power minus 1 by 1. So I am not writing down by 1 here because it is the same, right? So now x to the power minus 1. This part is x to the power minus 1. This is so this is our minus is here, and x to the power minus 1 is 1 by x, right? Do you guys know
Yes.
this? X to the power minus 1
Yes.
is 1 by x. So our answer is minus 1 by x. So I write here minus 1 by x. And then we have integration of x squared dx. So again, you just increase the power by 1 and just divide by the power, okay? And integration of a constant value, it will be constant into x. And then we write down c on the last. I think these four are very simple. Now let's go to some complex example. So here we have integration of minus sec square x by 3. So again, you can just take this take this constant out, right? Out of the integration sign. And then sec square, then we have sec square x. So integration of sec square x is 10x. Do you remember from the formula?
Yeah.
Okay. So then we get minus 1 by 3 10x plus c. The next one, integration of 3 e to the power x plus 1 by x plus 1 dx. So we know that integration of e to the power x, this is the same. So we so this constant is here, and integration of e to the power x, this is also e to the power x. Okay. And integration of 1 by x, this is our formula, like integration of 1 by x is equal to ln x. Do you remember? Integration of 1 by x equal to ln x, right? Formula 3. And then integration of on, this is as this is a constant, so it will be on into x, that means only x plus c. So this is the answer of 6. And 7, we have integration of tan square x. So we know that sin square theta, sin square x plus cos square x equal to 1, right? And then we also know that sec square x equal 1 plus tan square x. And cosec square x equal 1 plus cot square x. So these three formula we learned in our maybe level in our class 9 or 10 in our high school. So cos square x, it will be 1 plus, sorry, sec square x, cosec square x, okay, cosec square x. Cosec square x equal to 1 plus cot square x, right? So here in tan square x, here we have tan square x, right? So if you just take this on